So in 7.4, there's different ways to find the area of a triangle. Okay, a lot of you are familiar with this formula. The area of a triangle is equal to what? What's the formula always now? 1/2 the base of the triangle times the height of the triangle. Most easily identified in a right triangle, because this would be the height and this would be the base. So to find the area, I would just multiply height times base, which technically a right triangle is half of a rectangle. So area of a rectangle is length times width, where I cut that in half, I find the diagonal triangle. Okay. So all we're going to do here is tackle on this sine of C, sine of A, sine of B. What happens if it's not a nice, neat right triangle? Okay? And how would I be able to find it using something that was oblique? Okay? This can be pulled out of this problem. We just have to tackle on a sine of 90 degrees. So if that was my angle, C, right? If I take the sine of 90, what do I get? 1. And B and H are the two sides adjacent to that. So when I use these three formulas, I'm picking the sides adjacent to the given angle. A and B are adjacent to C. If I have an oblique triangle, A and B are adjacent to C. Next to angle B is sides A and C, and next to angle A are sides B and C. So if I pick the adjacent sides to any given angle that I know, and I plug into this formula, I can find the area of the triangle overall. So let's go ahead and try it. Draw a picture where the angle B is 72 degrees, side A is 105, and side C is 64 units, whatever that is. If I'm trying to find the area of this triangle, once I draw my picture, all I'm worried about is taking the two adjacent sides, taking their product and dividing it by 2 or multiplying it by 1/2, and then multiplying it by the sine of the angle in between those two sides. So at this point, since 72 is not a united circle, I'm going to have to use my calculator, and I want to go ahead and plug that in there. So 1/2 of 64 is 32. 32 times 1 of 5. I end up with an area roughly around 3,195. 550?
Yeah, it's 550.
Round to 3 decimal places. Approximately, always round to 3 decimal places unless otherwise stated. What's it round to? So, go ahead and try that for number 15 now. Same type of process. Once I feel like everyone's got something written down, I'll kind of show you what I have. Always want to make sure you draw a picture. To use my area formula, what do I need? Two sides of an angle. Right now I have one side and two angles. So I'm going to have to use what to find a missing side? law of sines. And which side in particular do I want to find? Probably C, side C, because C is then I have two sides between the angle 61 degrees. So I want to pick two sides that are going to be around a certain angle. Sine of angle C, which 61 plus 30 subtracted from 180. It's going to give me 89. Cross multiply and divide. Little c is going to be equal to 12 times the sine of 89 degrees all over the sine of 30 degrees. Which is really just equal to 1/2. So 12 times 2 is 24. Sine of 30 degrees is really just 1/2. 24 times the sine of 89. Gives me a length of 23.996. Point ... Remembering that's not my final answer, so I don't want to round just quite yet. If I round too soon, I could ruin my approximation. And then I'm going to find the area using angle B. So angle B is right here. The two sides that I'm going to use are the two sides around that. So 1/2. 12 times the side C times the sine of 61 degrees times 12 divided by 2 multiplied to the sine of 61 degrees. What do you guys get for the area? We hold
125.926.
Yes, 125.926. They don't give me any units, so you don't have to put anything. You could put units squared technically, but again, if no units are given, you're not expected to include units in your answer. Right? So, Haran, I guess is how you say that? Heron? 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 Yeah, there you go. Heron's area formula. Given any triangle with the side lengths of A, B, and C, find the area of the triangle. So, if you have any triangle, doesn't matter if it's oblique, if it's right, no matter what, we can always find the area. It does somehow come out of the fact that A squared plus B squared equals C squared, but that's only a specific case when what? A right triangle. But this one works for all triangles. So, fun fact, the S stands for the semi-perimeter, which is interesting because it's taking the sides and dividing it by 2. It's semicircle, half of a circle, semi-perimeter, it's half the perimeter. So, I had to figure out first what the sum of the three sides are divided by 2 and use that within this formula. So, the area of a triangle here is the square root of the semi-perimeter times the quantity of the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Take the product of those four numbers and take the square root, and that's your area of a triangle. So we have a triangular garden here that has the side lengths of 16, 19, and 25. We want to find the area of that triangle. Because 16 and 19 add up to greater than 25, I know it is a triangle. So I can kind of approximate here and give me something that looks something like it could be that triangle, 16, 19, 25. And if we're going to use herons, or however you call it, we're going to use this formula. We're going to go ahead and find the semi-perimeter. Here we go. 16, 19, 25. Focus. Let's go. What do I find for my semi-perimeter? It's what?
30.
It's 30.
It's 30.
Well, when I add up 6 and 9, that gives me 15. 15 plus 5 is 20. Plus 20, 30, 40, 50, 60, right? When I add up those three numbers, I get 60 divided by 2, which equals 30. My semi-perimeter is 30. So, in Heron's, or whatever his name is, 30 is the semi-perimeter times all these, or the difference of the semi-perimeter to all the sides. So, in my head, I can think, okay, I'm just going to do 30 minus 25, which is 5. And then 16 minus 30 is 14. And then 19 minus 30 is 11. So, where do we get 5, 14, 11? By taking the semi-perimeter, taking these three lengths away from the semi-perimeter. So now I'm going to multiply all these together and take the square root. So 30 times 5 times. You get it?
I heard you got one more than that. 1550. No. 1350.
You get 1350.
Real quickly here, once I find that actual area, I want to make sure I include my units. So looking back at the problem, since all the side lengths are in feet, my units are in feet squared.
What's the height?
All right. Now, we're able to go ahead and take this formula a step further. If we had Heron's, I think it comes from this. Let's see if it works. Heron's? Sure, whatever. So, if that's how I found it for any side lengths, what happens if A, B, and C are all the same, right? What if they're all the same? So if they were all the same, no, that's not working. That should work, but I don't know how it does work. I never did it that way. I always thought about it first as an we could try to go through that process. Not right now, but maybe later. But if I have an equilateral triangle where all the sides are the same length, how would you find the area of that triangle? Humor me here for a second so we can figure out where this came from. Because you could just accept it, but it'd be way more entertaining if we knew where it came from. How do I find the area of an equilateral triangle if I didn't have this formula? 1/2 the base times the height, right? However, I need to figure out what the height of this triangle is. This is an equilateral triangle, right? And this is just S, side. We don't know what it is. So this S is split in half, so this becomes S divided by 2 and S divided by 2 on either side of it. Do I know anything about the angles?
No, they have to be the same.
They all have to be the same, so what do all the angles in an equilateral triangle have to be?
30, 60, 90 triangle.
So, it becomes a 30, 60, 90 triangle, right?
On this side is.
That means the other one has to.
So, if it's a 30, 60, 90, right, this side is S divided by 2. And this side we don't know, this is S, and we need to find the height with respect to S. So if I look at my 30, 60, 90, okay, opposite of the 60-degree angle is A times the square root of 3. Here, A is what? S over 2. So really this is going to be H is equal to S divided by 2 times the square root of 3, or S square root of 3 over 2. That's the height, right, with respect to S. Now, 1/2 the base, which we said is what? What's the base of this whole triangle? S times the height, which we said is S times the square root of 3 over 2. Collapse that together by multiplying. You get S squared times the square root of 3, all divided by 4. Okay? So, personally, not even worth my memorizing, really. Because If I know it's equilateral, I can kind of use my 30, 60, 90s to get there anyways. So if you want to memorize it, fine. If you don't feel like it's worth your brain power, okay, try to figure out where it comes from. So find the exact value of the area of an equilateral triangle where the sides are 6. So once I know the formula, it's pretty easy, right? (36 divided by 4). 36 divided by 4. 9. So my final answer is 9 square root of 3 centimeters squared. They do want the exact value, not the rounded value, so I'm going to leave it in terms of square root of 3. And guys, guess what? That is it for 7.4.